Hi guys, welcome back everyone. Today we are taking a giant leap into the world of advanced deep learning. So we will cover two powerful types of neural networks. The first one is CNN. We also called it convolutional neural networks for image data, and the second one is RNN, which is recurrent neural networks, specifically long short term memory, which is LSTMs for sequential data. So get ready for practical coding demonstration and clear explanation. So first, we understanding the convolutional neural networks. So convolutional neural network or CNN, these networks are specially designed to process visual data like images. They can identify features such as edges, shapes, or objects and which are commonly used in applications like facial recognition and autonomous vehicles. Key CNN concepts explained. So the first one is the convolutional layer, which is extract features from input images using filters. The second one is pooling layer, which reduces the image size while retaining important features. The third one is fully connected layer, combines all detect features for classification. And in the pooling layer, we also reduce the it also reduce the image size while retaining important features, making the network faster and less prone to overfitting. So demonstration and explanation of the code. First we will write the code. uh, First we import our libraries. So the first one is import TensorFlow STF. The second one is from TensorFlow dot keras dot models. So import sequential. Okay, now the second one is from TensorFlow dot keras dot layers. So import con 2D max pooling, 2D flatten and dense. Max floating 2D and flatten and dense. Now after this, from TensorFlow dot keras dot datasets. So import MNIST, and the last one is the TensorFlow dot keras utils, import to categorical. Okay, now the first step is load and pre-process the data and pre-process the data. So first, x underscore train, y underscore train. Okay, now after this, x test and y test, y underscore test, so which is equal to MNIST dot load data. Now reshape and normalize the image data and normalize the data. So x underscore train equal to x underscore train. So dot reshape, which is minus 1, 28, 28, and 1 dot as type float 32. So we don't need this as type. So we directly divide the 255.0. Now the next one is x underscore test equal to x underscore test dot reshape minus 1, 28, 28, 1 and divided by 255.0. Okay, now the next one is one hot encoded labels. Okay, so y underscore train equal to, so we don't need a number of classes. Remove this one and this one as well. So I'm using Google Colab. So that's why it's suggest by the AI. So it will develop the code in the fast manner. So now run the code. Okay, we get an error. Okay, so from TensorFlow.Keras, if your import is failing due to the missing packages, you can manually install dependency using the IPAP. This is the view example of installing some common dependency. Click the example below. So where we can get error. So conv 2D, max pooling 2D, flatten, dense. Okay, so there is a spelling mistake in layers. Okay, so the MNIST dataset contains image of hand drawn digits from 0 to 9. So we reshape the images to include a single channel in 28 into 1 and normalize pixels values between 0 and 1 to improve model performance. And the labels are converted to categorical format for multi-class classification. Okay, now the step 2 is define the CNN model. Okay, so CNN underscore model equal to sequential. Okay, now conversion v 2D. Now it will get some arguments. The first one is 32, and I will press the tab. Okay, so 33. This one is also okay. Activation rule is relu, and the input shape is yes 28 1, and the max pooling 2D. So the pool size is it will need to change pool underscore size, which is equal to so the rest of the flatten, so comma after this removing these two. Now use dense 128 activation equal to relu 128, and the activation rule is relu, and the dense activation equal to soft max. Now the step 3 is to compile the model. Compile the model. So for this CNN underscore model dot fit dot compile. So optimizer equal to Adam, and the loss of categorical cross entropy, and the matrices which is accuracy, and the step 4 is CNN model dot fit x train y train epochs 5 validation underscore split. We missed that one. Validation underscore split equal to 0.1 comma, and the batch size is 32, and closing bracket. Okay, now the step 5 is evaluate the model. So test underscore loss, test underscore accuracy equal to c nn underscore model dot evaluate. So the x test and y test, and the test here we use this and f. Now run the code. Okay, so the conversion 2D layer applies filter to detect patterns like edges in the image, and the max pooling 2D, this one layer, which is downsamples the image to reduce complexity and prevent overfitting, and the flatten prepares the data for the fully connected layers. So we use the Adam optimizer and categorical class entropy, which allows to train the network efficiently. Now the epoch runs for 5 times, so it will take some time. So in the first run, accuracy 0.9076, loss 0.31, and in the next one, the accuracy it shows 0.98. So here I will fast the video and you can see result at the end. Okay, now here you can see the test accuracy result, which is 0.99. Okay, so the second part is understanding recurrent neural networks and LSTMs. So now let's shift gears to recurrent neural networks and their powerful variant, which is LSTM, which is stand for long short-term memory networks. So RNNs are great for sequential data like predicting stock prices and analyzing text data. However, they often struggle to retain long-term dependencies. So this is where LSTMs shine. So key concepts of RNN or LSTMs, which is the first one, RNN pass information sequentially from one node to the next, learning patterns over time, and LSTMs, which is use memory cells and gates to retain long-term dependencies, overcoming the limitation of traditional RNNs. So let's do some code to understand the concept of recurrent neural networks. So first we need to import our libraries. So from tensor flow dot keras model, keras dot models import sequential. Now the second one is from tensorflow dot keras dot layers import LSTM and dense. Now import numpy as np. Okay, so the step one is generate a synthetic sequential data. Okay, so x underscore train equal to np dot array. So here we use I plus j. So here we use for I in range, which is 5, and the last one is for j in range, which is 100. Okay, now the next one is y underscore train equal to np dot array. So here we use I plus 5 for I in range 100. Okay, now after this, reshape the data for LSTM input. X underscore train equal to train dot reshape. So the first one is 100, 5, and 1. Okay, now run the code and check if there is any error. So x underscore train, okay, which is equal. Okay, so we create a synthetic sequential data to simulate time series input, and the data is reshaped to fit the LSTM input format. So the first argument is for samples, time steps, and features. Okay, now the step 2 is define the LSTM model. Okay, so LSTM underscore model equal to sequential. So here LSTM, now pass the argument. The first one is 50. Activation rule is relu. Okay, the next one is input shape. so which is equal to 5 and 1. Okay, so after this dense, which is 1. Okay, so step 3 is compile the model. So LSTM underscore model dot compile optimizer Adam and loss MSE, which is a mean squared error. Mean squared error. And the step 4 is so LSTM model dot fit X train Y train epochs 200 and the verbose equal to 1. I'm using the 1 to see the result. Now run the code and wait for it because epochs run for 200 times. So the LSTM layer learns a pattern in sequential data over multiple time steps. So here we use the mean squared error loss for regression tasks and the Adam optimizer for efficient learning. So we okay. So the loss is at the last one is 0.0086. So today we explored two advanced deep learning techniques: CNN for image data and LSTMs for sequential data. These techniques form the backbone of many AI driven applications today. If you found this tutorial helpful, so don't forget to like, subscribe, and comment with your thoughts. Have a good day.